All right, y'all, let's quickly review what we know so far. So first of all, we know that if we drop an altitude and we make three similar right triangles, you can use, in this case, we know the altitude. So we would use SAAS. And over here, we know the hypotenuse, so we would use HLLS. And if we were to set this up, we would use this part, 36, over the altitude, 48, and equal to 48 over, and now this side right here, this part is going to be 36, or x minus 36. So then we would simply get our calculators out and cross multiply. So 48 times 48 is 2,304. And then you have to set this in parentheses. So this would be 36x minus 36 times 36, which is 1,296. So then we add this first. So 2,304 plus, you get 3,600. Then we're going to divide by 36. And so that would make x equal to 100. So in this case, we got x equal to 100. Okay. Now over here, we're going to use HLLS. We don't know our hypotenuse, but we do know that if we add these two sides together, it'll give us our hypotenuse. So we're going to do x plus 9 over the leg. Remember, we're looking at the big triangle. So that'd be 15 equals 15 over the part that's connected to the smaller triangle. So that's 9. So again, we need our parentheses. So we get 9x plus 81 equals 225. So I'm going to take 225, subtract 81. That's 144. Divide that by 9. You should end up with x equaling 60. That was day 1 of this unit. Then day 2, we were looking at if you have a special right triangle. So this would be a 30, 60. Okay? And so what is the rule? Well, this is our right angle here, right? So we're looking for the hypotenuse, and we know the short side. So this is the short leg, okay? And so if we have the short leg and the hypotenuse, you got to go back and consult your notes. And so what it says on your notes is that it's a 30, 60. If you're looking for the hypotenuse, you just take 2 times the short leg. And so since we know the short leg is 60, you just take 16 to find x. 16 times 2, which equals 32. So the hypotenuse in this case would equal 32. Okay, so now we're going to go ahead. What if you can't make similar triangles? And what if you don't have a special triangle? Okay, and this is where trig comes in. And these are a couple songs that we're going to listen to a lot. So get ready to get tricky with it, is all I'm saying. This is trigonometry. This works for all right triangles, regardless if they're special or not. And so in order to do this successfully, you have to know your ratios. So one thing we have is we have something called sine. And you're going to have a right triangle, and you're going to have a hypotenuse. That's what you can always label, but then it depends on whatever angle you're looking at. But the ratio for sine is always going to be the opposite side over the hypotenuse. And we call that O over H, or we say SOH. So that's how we pronounce it. And then you've got cosine, and cosine is always going to be the adjacent side over your hypotenuse. And this will make more sense when we start looking at hypotenuse. And so we say A over H, or we call this ka. And then the last one's tangent. And the tangent is when you're trying to find the hypotenuse. So it's opposite over adjacent. Now the good thing about trig is that a lot of what you need to do is just simply done in your calculator. And we say TOA for this one. So the mnemonic device is so, ka, TOA. And I learned that when I was in high school, and we're still using the same mnemonic. So again, these are side related to an angle. Sides related to an angle. These are ratios, right? So now let's go ahead and take a look. So this is what you need to know. These are your notes. This is the meat of what you need to know. And this should be an A, not an H. All right, so let's look at an example problem. Here's what it looks like. So we want to find the trig ratios. So this is an angle, and we call this angle theta. It's just a Greek letter. So first thing we want to do is we want to find the sine of theta. So we do that by remembering our SOHCAHTOA, okay? So let's go ahead. Sine is going to be opposite over hypotenuse. So if I'm looking for the sine of theta, I look across from theta, and the opposite angle is 15. And then I look at the hypotenuse. Well, the hypotenuse is always going to be 35 in this problem. And then I simplify it, and I get 3 over 7. Because both 15 divided by 5 is 3, and 35 divided by 5 is 7. So that's how I got 3 over 7. Okay, cosine, I'm going to be looking at the adjacent and the hypotenuse. So if I look at theta, the side that's adjacent is right here, number 7. So it's going to be 7 over 35. And that can be simplified as well by dividing the top and the bottom by 7. And you end up with 1 over 5. So cosine, again, is adjacent over hypotenuse. And lastly, we're going to look at the tangent. Well, the tangent is going to be the opposite over the adjacent. And so again, I know theta is here, so the opposite side is 15 over 7. And 15 over 7 cannot be simplified, so I just leave it like it is. So this is how you set up your trig ratios. Now let's see if we can figure out how to apply them. So here we go. We've got a problem here that we're going to work on. And the first thing we want to do is we want to find the sine of C. So I'm going to look here. This is angle C. Right? So the sine, again, I'm going to write SOHCAHTOA, so I can remember. So I'm looking at opposite over hypotenuse. I know this is always going to be my hypotenuse because it's across from the right angle. So I'm going to look across from C, and I end up at 12. So this is 12 over 13. That's it. I'm done. Next, we're going to look at the cosine of B. So if I'm looking at cosine, I'm looking at adjacent over hypotenuse. And so for B, this is the side that's adjacent. So it's adjacent over hypotenuse. So that's going to be 12 over 13. I'm done. And if you notice, the sine of C is the same as the cosine of B. That's kind of interesting. All right, so now we're going to look at the tangent of B. So here's B. Tangent is opposite over hypotenuse. Opposite over adjacent. And the opposite side is 5. and the adjacent side is 12. So the tangent of B is just 5 over 12. And the cosine of C, so cosine again is adjacent over hypotenuse. So the cosine of C is the adjacent side. In this case, it's going to be this side right here, 5, because that's the one that touches. And the hypotenuse is 13. And the tangent of C is going to be opposite over adjacent. So opposite is 12 over the adjacent side, which is 5. Okay. So why don't you go ahead and try these on your phone. Pause the video. Okay, well, if you notice that the tangent A, you actually cannot use your right angle as one of the angles that you're using for your trig ratio. So you actually, it's kind of a trick question, but you actually can't find the tangent of A or the cosine of A. But you can find the sine of B. And so sine, I'm going to first look, is opposite over hypotenuse. And so the opposite side is 5, and the hypotenuse is 13. So the only one you could actually solve is that one there. Here are some more examples. So the first thing you want to do is you want to make sure that you're using your calculator. And we're going to go first, take your calculator out, and you're going to hit the mode button. Turn it on, hit mode. It's right next to the second button. And you want to make sure that you scroll down. And radians should be highlighted. If you want to scroll over to degree, hit enter, and then second quit. So you've got to make sure that your mode is in degrees. So you go to mode and select degrees. Otherwise, these will not come out right. Okay, so now we're going to use our trig ratio to figure out what an angle measure is. And so we're going to work backwards. And so you also have to know how to use the inverse. So if you look, you'll see sine, cosine, and tangent. You'll see those buttons on your calculator. And then above it, you'll see sine to the -1, cosine to the -1, and tangent to the -1. And those are called inverse operations. So if you want to undo one, you use the other. So if I want to figure out what x is, I need to get rid of the cosine. So I'm going to multiply both sides by the inverse of cosine. So I'm going to multiply this side by cosine -1. And so when I'm typing this in my calculator, I'm going to put cosine -1 parentheses square root of 3 divided by 2. So you're going to hit second cosine, and then you hit second x squared, 3 divided by 2, close your parentheses, and hit enter. Second cosine, second square root of 3, you got to tab over, my bad, divided by 2 equals, so you should end up with 30. And this is in degrees, okay? So over here, we're going to do the same thing for sine, except we have to do the inverse of sine. So you're going to multiply both sides by sine inverse. So when you're typing this, these cancel out. That happened over here as well. So that's how you get x by itself. So x is going to equal sine -1, 1 over 2. Okay, so when you type it in your calculator, second sine 1 divided by 2 equals, interesting, you also get. The last one is tangent x equals 1. So once again, to get rid of tangent, you're going to multiply by the inverse of tangent. It's kind of like taking the square root of something that's squared. You end up canceling it out. So we get x is going to equal tangent, inverse tangent, times 1. So second tangent, 1, close your parentheses, hit enter, and you should get 45 degrees. Make sure you can do these on your own. Pause the video, and you can come back and check your answers. You should have gotten 60 degrees for each one.